I'm here with Jesse Cedarbaum. I'm Bernard Ravina. It's the 20th International Congress of Parkinson's and Movement Disorders in Berlin. It's June 2016. Why don't we just start off, Jesse, talking a little bit about your neuroscience education, how you got interested in neuroscience and eventually interested in Parkinson's and movement disorders.
Where to start?
Junior high school,
Junior
high school.
I started at a very young age. Now, my interest in neuroscience actually started in college, I had family members with Parkinson's disease, and some were in the very early trials with Levodopa. And my freshman year in college, I took a course was called Human Biology, and I was actually co-taught by members of the medical school and various departments around Stanford where I went, and a section of it focused on catecholamines and mood disorders. And I found it fascinating that this chemical, this drug that I'd come to associate with motor function, was also associated with mood and cognitive function.
Right.
And from that point on, I was hooked. I ended up doing neuroscience most of my time in college in some way, shape, or form. Went to medical school. Decided that psychiatry was too passive for me, and I enjoyed the medicine and was drawn to the phenomenology of and the intellectual challenge of neurology. At the time, we didn't have even CT scanners. We're dating ourselves here. Until actually I spent some time at Queen Square during medical school, where they had the first CT scanner. And, wow, the ability to look into the brain and thinking about the possibilities of how one could, even try to image the brain in action and learn about how the brain functioned. But I still wasn't specifically interested in Parkinson's disease, even though it had touched my family. So I sort of fell into it then by accident. After residency, I had an opportunity
Residency was at
Residency
Cornell?
was at Cornell, yeah. Medical school was at Yale, and at that point I actually spent several years working the locus ceruleus and trying to understand what this mysterious black spot was in my thesis. Actually, when I was researching the background for my thesis is when I first came across David Marsden's writings, and the fact that the locus ceruleus was involved in Parkinson's disease. And so that sort of started triggering the interest more, and I ended up, after my residency at Cornell, staying on and working with Fletcher McDowell. Fletcher was, to my mind, get choked up here. We talk about people who are influences on you. Was really one of the my great teachers in neurology, and had a lot of contributions. He was one of the people, along with Meliar, who recognized the significance of the work that Hornikevich had done, especially George Contius's approach of gradually building up the oral dose of levodopa, and also the application of decarboxylase inhibitors. So
gradually building up so that people would tolerate it.
Tolerate it, yeah. And Fletcher actually brought George to Cornell. Fletcher ran one of the first clinical trials with levodopa, which
clinical trials as they were
known then, not double-blind, placebo-controlled. But he, Meliar, Harold Klawans, those were the guys who were doing this. And no, they were not double-blind, placebo-controlled trials, but you couldn't double-blind those trials, because when they got up to a certain dose, patients got out of bed and started walking. So it's something we don't appreciate that now,
No, it's funny. We don't have that kind of magnitude of effect
Yeah,
now.
I mean, these were people who are, now what we consider moderate to advanced Parkinson's disease who were in these studies, and it was like a miracle, like the movie Awakenings.
Yeah.
So I started working with Fletcher, and it was actually a very unique situation, because we were based in a rehabilitation center, Burke Rehabilitation Center in White Plains, New York. And we also had a clinic at Cornell Medical School in the city, but at Burke we could admit patients under the guise back in the day of medication adjustment and rehabilitation.
Right.
So we had the opportunity to observe people, adjust their medications, do pharmacokinetic studies in-house, in a setting that was very comfortable for the patients. It wasn't a hospital ward or a busy clinic. So it was a really, really unique opportunity. And two things came out of that. One was the opportunity to see what had happened. Now, 16 years later was when I came on board in 1983, after many of these people had been on levodopa for that long.
That's an amazing opportunity.
It was an amazing opportunity to see these people, see what had happened to them, and and the observations that came out of that were quite interesting. The first thing was the prevalence of cognitive impairment and dementia. Just doing simple mini mental status exams and interviewing the patients and their families, it was quite clear that by 10, 15 years in, most patients couldn't manage their own affairs.
Right. And this was kind of mid-1980s, so people had started levodopa around late 60s or 70s.
Yeah. So we actually presented this at the ANA in 1986, I think, was when we first presented this, the later iteration, this he'd had intermediate time points. The second thing was having the benefit of the experience and watching the emergence of response fluctuations. And so and it was right around the time that Merck and Roche were starting to develop the long-acting Sinemets, Matapar HBr and Sinemets CR. So we were involved in some of the very early clinical trials with Sinemets CR. And I'll come back to that, but the observation, looking at the data, we realized that the duration of treatment really had nothing to do with the emergence of dyskinesias and fluctuations.
This is a very interesting observation.
And so, in the same issue of Neurology, we published a paper, and Fabrizio Stocchi published a paper with the same observation, that what mattered was age and maybe perhaps to some extent initial severity, but the earlier the age of onset, the more likely the dyskinesia and the emergence of response fluctuation. The people who developed disease later on had much, much less of this.
Was cumulative dose versus duration?
We could not find.
So it was more patient characteristics than
we could not find an association with levodopa exposure, and there hadn't been any agonists up to this point to speak of. So that was very controversial at the time. And I remember, so Fabrizio and I published these papers, and Neurology published them back to back. Bill Landau wrote an editorial because there was this, at the time it was, should you delay levodopa? Is it bad for you? Does it cause fluctuations to make Parkinson's worse? We also showed that the progression was not any different than one would expect. And Bill Landau, in his inimitable way, wrote an editorial. The punchline was, well, now the score is data 2, dogma 0.
That's nice.
And I think
but no neuromythology. No neuropathology.
Right. And I think that was the first salvo in, can we really start to treat people early, and should we start to treat people early? Which from that point on became my philosophy. And also from that came the realization, and other people were working in this area, Tom Chase, Morel Moradian, Jay Nutt, looking at the relationship of levodopa pharmacokinetics to the emergence of response fluctuations, also the Mayo Group, also at that time, and characterizing the pharmacokinetic behavior of levodopa and the temporal association with fluctuations. So the obvious thing is, well, can we, if we can prolong the exposure of levodopa in the blood, can we reduce fluctuations? And as everybody knows, that's a problem that's still not solved all these years later. and it's somewhat intimidating to me, the observations that we've missed over that time.
Yeah.
But we had the opportunity to participate in the earliest trials with Cinemet CR.
Right.
And it was really interesting. When we came to the observation, the understanding out of that was the gastric emptying, which was really limiting.
Right.
And to some extent that the gut was dyskinetic.
Right.
Because gastric emptying became erratic,
Right.
which is why Jake Sage did and we started with the jejunal infusions, because we couldn't do the intravenous infusions. And I remember one patient we had, literally at that time, it was way before Duodopa, they would crush up their Cinemet tablets,
run them
early
through formulation,
run them through a Belita coffee filter. They had an gizmo with an IV bag, these backpacks, they're like bicycle riders wear now. And he walked around with his, he was an engineer, so he helped, this is the first patient we did, he helped with a lot of this.
The kind of people you want to hire at a company.
Yeah. And we still saw, that helped somewhat.
Right.
But that came to the realization that the gastrointestinal tract was probably dyskinetic, along with the rest of the patient. Never really clicked about the notion of synuclein. Is there synuclein pathology, or is there Parkinson pathology in the gut?
This was at least a decade prior to
synuclein.
synuclein.
But is there Parkinson pathology in the gut? And what's that telling us about the disease? But nonetheless, that was the observation that was made. It was a great opportunity, a great window into neuropharmacology, and for me in my later career now in industry, the importance of pharmacokinetics and formulation and everything. Things like you guys like you and me think about all the time now, but we didn't really appreciate back then. And the crude way we were doing things with fluctuation diaries and stuff like that.
Still are in a lot of ways. So it's really interesting, though, that within the first 15 to 20 years of experience with levodopa, you had characterized a lot of the issues that we're really still working on today. That really struck me, just hearing your comments and also looking at some of your old papers. Within that first 16 years of experience in the initial 100 patients, you wrote about, you're saying, incidents of dementia, and you characterized response fluctuations. These are all the same things we're dealing with today. We'd measured dementia in different ways. I think you said you just used a mini-mental. But by and large, you'd see the same kind of papers.
And ultimately, I left academics in 1990 and went to industry, partly because of the lure of working on the potential of growth factors, which, as we know, haven't panned out for preventing, for neuroprotection in Parkinson's disease. And rapidly we discovered the challenge of delivering neurotrophic factors or any proteins to the brain. And obviously what you're doing now with gene therapy is partly a result of that, right? And so I got away from Parkinson's in around 1990. And periodically would drop back into...
Let me ask you, before you go, so what made you leave academics and go into industry? Was it wanting to do drug development from scratch? Because you would participate in some of the sort of foundational studies of levodopa.
So I think the first thing that got me interested in it was Datatop. So we were sort of in the backwater of neurology out there at Berk, and I was new in the field, and so we really didn't have an established movement disorder program. And when they went looking, with PSG went looking around, and NIH went looking around for people to review the Datatop grant and be on the monitoring committee for the study. There are very few people in the United States
but
to go to. And so I ended up having the opportunity of looking at Datatop from the outside. But that got me interested in how trials are done and managed. And also my exposure with the Cinemet CR program and other clinical trial programs, I was young and fearless and thought I could do it better.
Yeah, yeah.
So when my colleague Glenn Schleifer approached me about joining Regeneron and showed me this amazing data of how neurotrophic factors could support survival of dopamine neurons in a dish, I said, wow, here's a chance to be on the cutting edge of science, as well as sort of recreate, create the clinical trial enterprise and figure out ways of trying to be proactive and interact with regulators in a positive way, and work with networks like the PSG. And I thought I could have the best of both worlds of academics.
Sounds like what I think
and science, and in truth, for those young people who might watch this, not that we don't need active researchers and people doing patient care in academia, industry provides you a lot of very interesting opportunities. So it was being seduced by that, by the ability to really be on the cutting edge. And I've learned a lot. I learned a lot in doing non-Parkinson stuff that actually translated into a lot of what I've done in other places. And I took a lot of my Parkinson's learnings with me. So it turned out to be impossible to really deliver protein growth factors in the brain, particularly the ones we were working with. They were very sticky proteins. They're probably that way because they need to act locally, and you don't want them spreading around and doing mischief. So sometimes you just can't beat Mother Nature. So we ended up moving our emphasis out into the periphery and looking at ALS. And at the time, the way people were doing ALS trials was by measuring muscle strength with these complicated apparatuses of pulleys and strain gauges and getting people into all kinds of awkward positions to measure muscle strength. But no one was really looking at how is the disease affecting patients in their daily lives.
So people were using was the TQNE, the Tufts quantitative neuromuscular.
Exactly. Tufts, you remember that. So this is where the experience in Parkinson's disease, where we really, part of the field was very, focused on the patient early on. We had the Columbia Rating Scale, which morphed into the UPDRS. Fletcher and Charlie Markham had developed the Cornell UCLA scale, which was very similar. But these scales placed half their emphasis on the examination of the patient, and half of their emphasis on activities of daily living with the ADL inventory, which we now have as part 2 of the UPDRS. And that, it turns out, had a profound influence on the way we started designing trials for ALS, because we were able to ask the question, how does ALS affect the lives of patients? And so the ALS docs hadn't really thought about this. They thought about, can the patient breathe, and can they, how strong are they?
Which are very relevant, but they don't capture the whole functional picture.
And then, so what is the patient experience? What is the patient's life? So we brought together a group of experts, and we looked at a bunch of the existing rating scales for ALS, and we brought the UPDRS into the mix. Or not the UPDRS, but it was it was the UPDRS at the time.
What else was available? Was the Appel score?
There was the Appel score was available. There was the Norris score, and there was the TQNE. And some of these had some elements in, but no one really was focusing on what's the patient experience, how's the patient able to function. So we actually, and there was one other scale, a little scale guy, an otolaryngologist of all things in Seattle, called the Hillel scale. And we took elements of the UPDRS that we thought were relevant to ALS and brought in a few other things. And that's how we created the ALS Functional Rating Scale, which is still the outcome measure for all the ALS clinical trials today. So it can trace its lineage back to the UPDRS and Parkinson's disease.
I had never connected those until we started
so
talking about this.
You haven't read the papers, Bernard.
No, I had not. I had no reason to.
So Elton and Bond, that seminal paper is quoted in the first papers on the ALS-FRS. So Parkinson, the movement disorder community actually helped the ALS community
Yeah.
clinical research community move its
Yeah.
clinical trial paradigm along. Unfortunately, we still don't have any good drugs for ALS either, but
Right.
but that has generated a lot of useful science, and actually patients now use that. And I don't really see this happening in Parkinson's, but they actually go online and they talk about their ALS-FRS scores.
Yes.
They do them online.
Patients
in
like
registries.
me.
Yeah, patients
Right,
like
right.
me uses it.
Yeah.
And it's a great way to capture the patient experience remotely. As we talk about, we talk about digital health now and remote clinical trials and telehealth. The ability of patients to actually self-complete, parts of scales like that is something that that has come out of this whole experience.
So that's true. I had not appreciated it. You could see in trials and in people the crossover between Parkinson's, Huntington's, and ALS, but I hadn't appreciated the direct link in scales. And certainly we've tested a lot of the same drugs for supposed neuroprotective trials and things like that. But I also point out, so that is unique and probably increasingly uncommon that you had an opportunity to make important contributions in a movement disorder and in a neuromuscular disorder. We get so segregated in our training now. There's not that much crosstalk between them.
Yeah, and that's one of the good things about industry, because in my time in industry, got to work in ALS, got to work in peripheral neuropathy, got to work in retinal disease, which is something now, we're learning about the eye in Parkinson's disease. So, starting to think about what are the layers of the eye that are degenerating, how is ocular function being affected in Parkinson's disease. You can also take the learnings and move them across diseases. So I'll give you another example of where the UPDRS influenced, in my experience in Parkinson's disease, influenced thinking in another area, which is Alzheimer's disease, curiously enough. So several years later, when I was at Elan, working mostly on Alzheimer's, a little bit on Parkinson's.
So you spent about 15 years at
17
Regeneron?
years
17 years at Regeneron. That's an amazing duration. And you got in early, so that was a bit of a nervy move. No pun intended.
I was accused of going over to the dark side.
Well, it was a bit of an unknown at the time.
It was a big unknown.
But biotech in 1990 was a real unknown entity.
And for neurology, it was a big, big unknown.
Yeah.
And I was able to keep my academic appointments, and Warren Alano was gracious enough to allow me to come to the clinic and to rounds and things at Mount Sinai for several years. So we were able to keep up some of the collaborations that we had before. But that's an amazing opportunity you do have in industry, and you have. I think people don't appreciate the rigor. I mean, you've experienced it, but the rigor of the science and industry, because we have to. At the end of the day, it's not just a journal reviewer who's reviewing our paper; it's the FDA who's taking our original data and turning it upside down and shaking it around sideways, and coming at it with their own twists and their own analyses, and their own need to protect the health of the American public most of all. And it's a more rigorous. We have to meet a more rigorous review standard than anybody submitting a paper to a journal. And I think that changed me a lot.
It really does. It changes the way you approach things. Not that the approach in academics, which we both enjoyed, isn't rigorous or thorough in any way, but it does change the way you approach things when you know the way that it's going to be applied, that other people are going to turn it upside down, inside out. In that somebody might take this one day and they'll be relying on the quality of the data, right?
Right. I mean, the first thing is do no harm. And so doing no harm also means not doing good.
Right.
and so, because if patients take drugs or treatments that don't work because they believe in them or the data is insufficient, what can end up happening is they can miss the opportunity to take something that really can help them. And that's a form of harm. And so what's been, and it's really gratifying for me to see, like the program that the PDF has now, training patient advocates in research, is a very, very important step. And the Parkinson's community is way far out in front other therapeutic areas
Absolutely.
in doing that, and there, that's really to be acknowledged, that the importance of the patient voice in what we do, and keeping the patient at the center, which Oscar spoke about and Eduardo spoke about just now, this morning. Everything we do is about the patient ultimately, and
It's
you.
easy to lose given how much process there is now. It's easy to forget that.
And there's a lot of risk. I mean,
Yeah.
I've been involved at least in some way in the development of, I think I counted it 7 drugs that are in the clinic.
That's fantastic.
But there are a lot more that never make
Yeah,
it.
yeah,
There are important learnings from those.
right.
We like to think that biotech has a higher success rate but it doesn't. Things fail, and you have to pay attention to everything along the way: the manufacturing, the quality of the product you put out,
Right.
the way you collect your data, and I think the contact with industry has also been helpful for groups like the PSG.
Yeah.
In terms of the importance of having standard operating practices, documentation practices, educating physicians and their patients on the importance of patience
Right.
in,
Right.
in drug development. Even levodopa. Hornikevich gave the first doses or Carlson in 1960, maybe in the late 1950s.
Yeah.
And it really wasn't until 10 years later
Right.
that we figured out, because there was a time when it was dismissed because
Right.
a short pulse of drug
Yeah.
didn't work.
Right.
IV.
And nobody could tolerate
and
it, yeah.
And people threw up. and so it took until Katsias had his insight on gradually building up the dose. And then on decarboxylase inhibitors, which came around, I guess, in the early 1970s,
Right.
when levodopa really became a drug
Yeah.
that was accessible to the masses. So we think even something as simple and obvious as levodopa took 10 to 15 years
Isn't that amazing?
to get into
Yeah.
into mass circulation.
It's a really important point. I've been looking at sort of the life cycle of innovation, and so I've been working on gene therapy, and gene therapy kind of came into clinical trials in the 90s, and maybe is just really reaching some level of maturity now with promising late stage data. So you got a 25-year time frame, but it's amazing. Levodopa, even you kind of think of miracle drug, but still 10 to 15 years to get to a formulation where people could tolerate it, could be widely used. Yeah.
Think of synuclein, discovered in 1997.
Right.
The mutations,
Yeah.
right? And it's now in 2016,
Yeah.
19 years later, that synuclein-based therapies are finally entering the clinic.
Yeah, it really gives you perspective
Yeah,
on how
yeah.
complex these things are.
And it gives you an appreciation of the altruism of the patients and their families who are willing to participate in the studies and the drug development and donate
Right.
tissues and work with industry trials and academic researchers.
Right.
For, my hat goes off to them. I think about them a lot. I'm sure you do too.
Oh,
And we can't forget them.
Yeah.
They're so much at the center of this.
It's amazing. You mentioned synuclein. Huntington is virtually on the same timeline, right?
Yeah.
Mid-90s gene discovery. Everybody thought it would be 5 years to a cure or something
Yeah.
from there. And now you see the first kind of Huntington lowering, not allele specific, but the first sort of knockdown approaches to Huntington in clinic with ASOs, and hopefully, gene therapies, other knockdown approaches will be soon to follow. But
Yeah.
it's a pretty consistent timeline, right? It's like
It's
20
humbling.
years or so. It really
It's
is.
humbling.
It really is.
And so, for those investigators who see their discoveries eventually translated in drugs, it must be tremendously gratifying.
Yeah.
But it's a long haul and a lot of hard work by a lot of unsung people.
Yeah.
I keep thinking about the guys who invented the PCR machines,
Right.
who get and the technology, who get no credit, but without whom you and I wouldn't be doing what we're doing.
Yeah, absolutely.
So there are a lot of unsung heroes in this business, but we're sort of drifting off. I wanted to talk a little bit about how Parkinson's work and the UPDRS also influenced Alzheimer's.
Yeah, I want to hear about that. And you were one of the early people to talk about early intervention, which is relevant for Alzheimer's, Parkinson's. So go ahead. Yeah.
So after I left Regeneron, after all that time, as you pointed out, I went to Elan Pharmaceuticals, which ultimately spawned Prothena,
Right.
Which is in the clinic with us with an anti-synuclein antibody right now. They're working with Roche, and we have a different, slightly different antibody. But during that time, we were working on Alzheimer's disease, and it was a time when amyloid imaging was first coming along on the scene. And the anti-amyloid antibodies were coming up. We were working on other small molecule approaches to amyloid. And we realized it was starting to be, there'd always been this construct of mild cognitive impairment, or MCI. And as a prodromal Alzheimer's disease, if you will, but there were no biomarkers. And then with the availability of the biomarkers, and Alzheimer's been a little bit more fortunate than us, and that can see the aggregating protein imaging and little clearer separation on the CSF amyloid. We started thinking about how could we do prodromal Alzheimer's trials. This was now 2007, so we've come a lot farther forward in time. And remember, we were sitting around one day thinking, well, what can we use as a primary endpoint measure? Because at that point in Alzheimer's trials, you had to have a cognitive measure and a functional measure, which meant you had co-primaries, which meant you had to correct for multiplicity, and you reduced your power that way. You'd have to have very, very large trials.
So it was the ADAS-Cog and global clinical impression. And nobody knew what the ADAS-Cog meant in terms of amount of change.
In early early Alzheimer's disease, it didn't move very much. And as a matter of fact, there's data that
still doesn't.
But there are a couple papers out there that says basically it's even odds in early Alzheimer's disease. So there was this measure that had been developed at Washington University by Leonard Berg, and then subsequently really developed by John Morris and his colleagues, called the CDR sum of boxes, the Clinical Dimensional Rating Scale sum of boxes. And it was very interesting because it looked at 6 domains of function using a combination of structured interviews for patients and caregivers. And 3 of the domains were really focused on memory function. And on memory. And 3 were focused on activities of daily living. And
sound familiar.
Starting to sound familiar, right? So we actually, ultimately the drug died and didn't go anywhere. This often happens in industry. But we wrote a series of papers with folks at Elan, Michael Grunman, and a group in France, actually in Toulouse, where Olivier Rascol is based, but the Alzheimer's group there, showing that this measure actually performed very well from the prodromal phases of Alzheimer's disease into mild to moderate stages.
Better than the ADAS-Cog.
Better than the ADAS-Cog, more robustly, and that the functional and exam components, if you will, track together.
Interesting.
So this was a series of 3 papers, and what it actually, again, quoting Elton and Fahn, quoting the structure of the UPDRS, as a rationale for proposing this could be used just like the UPDRS, which we use either as part 2 and 3, or the whole scale, or one part or another, in clinical trials. For Parkinson's disease, you could do the same thing with the CDR sum of boxes. In Alzheimer's disease, ultimately this gained traction, and now the Biogen, the Roche clinical trials with all amyloid antibodies are out there using the CDR sum of boxes as their primary endpoints in prodromal Alzheimer's disease clinical trials. Again, tracing back to the UPDRS.
So tracking symptomatology with functional impact as being just that really robust combination.
And supported by the basic, neurological dysfunction. And correlating, embedding the 2 in the same scale. So that insight that came from Parkinson organically, because like I said, it came from Markham and McDowell, and it came from Elton and Fahn, and Stan with the group had done at Columbia and Milliar. That approach has now tracked into at least 2 other areas in neurology. At least. and some areas are struggling, like the Duchenne muscular dystrophy stuff, where they're relying on something
On a
like 6-minute walk,
yeah.
rather than can the kid go to school,
Right.
Can he get up off the floor, can he
Right.
swing from the jungle gym, that kind of
Yeah,
thing. They're
yeah.
focused on this 6-minute walk, which if I were an 8-year-old boy and someone was making me walk for 6 minutes, I mean, I would be off the wall.
First of all, why 6
Yeah,
minutes?
why 6 minutes? But this is a fundamental contribution that to how we approach the assessment of patients with neurologic disease that I think has welled up out of Parkinson's research. And there's so many people that have touched it that have been our teachers.
Yeah.
That you can't really attribute it in one place.
It's really, I hadn't realized the consistency of thinking throughout those different measures. I've done some work in the ataxias too, so I'll say at least one or other area in Friedreich's, the Friedreich's ataxia research scale, the FARS, a distinct offshoot of this tradition. But it is that understanding the phenomenology and then linking the functional impact.
Of course, ataxia people are movement disorders.
They are movement disorders, it's no mistake. I know there are a lot of people who are just an offshoot there. So, why do you think CDR sum of boxes, the cognitive elements in there are more responsive than the ADAS-Cog, or is it really the functional part of CDR sum of boxes that gives it more robustness early in disease?
It's two things. Alzheimer's is much more variable even than the diseases we deal with. And the way the CDR sum of boxes works is it's a structured interview. And the patient is always referred back to their own baseline, their own last visit. And so there are no absolutes.
Right, it's all that understanding change.
Because it's such a pleomorphic disorder, and it hits people in so many different ways. And I think even the heterogeneity we talk about in Parkinson's, we observe in Parkinson's disease or any of the movement disorders pales in comparison.
I agree.
To the heterogeneity. So that's the trick there. But the construct of carrying along what are the functional consequences of the disability, which is the magic thing.
So I want to take you back to some of your seminal Parkinson's work, because it's still really interesting and relevant. So going back, so a terrific span of consistent thinking across these diseases, but let's talk about, just in some more depth, the Levodopa Pharmacokinetics. So you did Levodopa Pharmacokinetics in the Periphery and in CSF, which turned out to be really interesting. Talk about that a little bit more, and also, we, based on what we've learned about the neuropathology, we think in advanced PD there's little or no, a few or no nigral terminals left in the putamen. How are PD patients still responding to levodopa?
That's a good question. So what you referred to are a couple studies we did with Warren Alano, where he had been one of the people who jumped on the observations about the fetal adrenal transplants. And so he had a group of people who had been transplanted who had Ommaya reservoirs, so they could be sampling the CSF.
Convenience sampling.
So this was a real convenience sample. These people were heroic people to undergo all this. And what we did is we administered a dose of levodopa. And because we were puzzling, one of the things that puzzled was the lag time between the start of levo, when you give a dose and when it actually kicks in. So what's causing that, and what are the consequences of that? And so this was a way of looking at and also how rapidly is levodopa getting converted to dopamine in the brain. And you're taking me way back, and I don't remember all the details of this work, but
I looked at it last night. I'm pretty fresh on it.
So, and there'd also be a lot of difficulty measuring dopamine itself in CSF. And so the two things we did was so we gave a dose of levodopa, and just like we do standard pharmacokinetic assessments and UPDRSs, when we were doing the Cinemet CR development work, we did the same things with these patients, except sampling through the Ommaya. What we saw was two things. Number one, dopamine is very hard to find in CSF, and we dug back in the literature and we found some papers by Manfred Munter and Gertrude Theis from the 70s, early 70s, where they found that dopamine in the CSF existed as conjugates, predominantly as a sulfate conjugate. And so if you deconjugate, if you had just added a sulfatase step or a boiling in perchloric acid, you were able to release the dopamine. So we're actually able to measure dopamine that way. And what we found was that the time course of either levodopa or dopamine in CSF precisely matched the time course of the motor response. Now these were people with very advanced PD, so it doesn't get at your question. So the conversion from levodopa to dopamine was superimposable. So there's no lag time there. So it meant that probably whatever lag there was absorption and then circulation time, and wasn't, at least in these patients. But I think
the emergence of dopamine in the CSF was almost precisely with patients turning on.
And the disappearance was with their going off. And so obviously the diffusion was very rapid. We didn't think to do things like, and we didn't have SSRIs, for example. So we couldn't see if, as I think it was Jeff Corderer mentioned yesterday, blocking the serotonin uptake site would prevent the conversion. So some young person out there who wants to do an interesting experiment and help answer this very important question. It could be done. It could actually be done in people with shunts who don't have Parkinson's disease. Very interesting question that could be answered, perhaps definitively. So that was a very, very instructive experiment. I think the understanding levodopa entry into the brain was another thing where one of the observations we had with one of the early Cinemet CR formulations is we ended up giving gobs and gobs of the stuff and people weren't getting better. And then they started turning off. And we were really wondering what's going on, so we started looking at the metabolites of dopamine, and this was one which floated in the stomach and wasn't released. And it turned out that O-methyldopa levels were going sky high. And the question was the O-methyldopa interfering with the entry of levodopa into the brain, or was something happening because of this particular formulation? It turned out that it was a function of the gastric retention time. And that entry into the brain actually at physiological concentrations with O-methyldopa was not important, and the way we got at this was with the support of Orion, who are the developers of entecapone. Mark Gutman, who was then at Montreal Neurological Institute, and I had the opportunity to look at fluorodopa scans in monkeys, either with or without COMT inhibitors. And we found the presence of, with entecapone or its predecessor, a peripheral COMT inhibitor did not affect levodopa uptake into the brain. So it was purely that the metabolism to O-methyldopa was acting as a sink. And when you do the mass balance, then it's probably true. So that also enabled the development of it was one of the experiments that enabled the development of the peripheral COMT inhibitors, because at that point there was a big debate: does the COMT inhibition have to be central as well as functional?
So why do you think that continuous duodenal infusions of levodopa don't completely eliminate off time?
Good question.
You bypass the gastric emptying issue, you get really nice plasma PK. In that, lag to getting into brain shouldn't be an issue with the fairly stable PK.
So there are things that are going on at the receptor level. And Jay Nutt has looked at this with apomorphine. One of the things we found in that experience is that dopamine receptors, probably D2 receptors, desensitize. And this has poured over into why you turn down Duodopa at night.
Right.
Or you don't really want to keep a patch on 24/7. So the first couple patients we did, we thought this is great. They're going to be able to get up and go to the bathroom at night.
Yeah, yeah.
And we left the pump running 24/7 on the original dose, and they froze up.
Yeah.
And one of them ended up with his typical end-dose dystonia continuously.
Right.
This is where ends of one help you generate.
Yes,
I can't say they prove
yeah.
anything, but they help you generate theses. And then we started turning off the pump at night.
Yeah.
And we found that he actually still had an early morning benefit.
Right.
But now he started being much, much better. He still had fluctuations during the day, but it was much, much better.
Right.
So there's something going on with
Yeah.
sensitization, desensitization of receptors. Another piece of the work with Warren, where Jay and his group got looped in, was looking at an amino acid challenge.
Right.
And in fact, a large amino acid challenge did decrease. So diet can also, can also affect how Dopa gets into the brain. So I don't recommend the paleo diet.
Right.
For Parkinson
That
patients.
would not be. Keep some carbs on board,
Yes.
right?
But keep a diet that normalizes gastric emptying.
Yeah.
Keep a diet with a low and steady protein, or not a low, but it's at least a consistent protein intake
Yeah.
through the day,
Yeah.
so you're not facing boluses of protein. There are probably other things that are going on that we
Yeah.
don't understand. Everything from the gut microbiome.
Right.
And to,
It is
you can just speculate all day and all night about this
I
stuff.
think the same findings you're talking about were true with continuous IV levodopa, right?
Yeah.
In, I think Tom Chase and Morel Moradian showed early on that even after they turned off an IV infusion, people's fluctuations didn't come back full force for a while, which suggests a lot of plasticity in the striatum.
There is, and I think there is some. Well, it's always been a mystery what the intermediate duration, long duration response. I mean, these were just described by Manfred Munter, fairly early on in the 1970s.
And then rediscovered in the L-Dopa trial.
Yeah.
Right.
There are a lot of things that have been rediscovered over and over again. And Jay Nutt has done a lot of work around this as well as of others. And so you wonder whether there are storage and reuptake sites like serotonergic terminals.
Yeah.
You wonder whether there probably are, we know there are post-receptor changes that go on. We don't know whether transporters are regulated. There has been a lot of work done on what are some of the gene changes and protein expression changes in striatum, and they affect channels. They affect all kinds of different. They affect receptors. It's not a simple story.
Yeah.
And even people going back to the 1990s. Chip Gerfen and other people trying to pull all this together. We still don't really have a good picture of the plastic changes in the brain. And Jeff Cordover made an interesting point yesterday in that we tend to, in our animal models, use young animals. And the old brain, well, going back to that early observation that we had, that age at disease onset was the major driver of when fluctuations, dyskinesias began. Probably because the young brain is much more plastic and able to respond and generate dyskinesias than the old brain isn't.
Yes.
So when we think about what you and I do every day in drug development, I think what Jeff said yesterday, that the age component is probably very important in driving the emergence of whatever subtype of disease people have. So you can put age on top of their genetic profile, on top of their genetics and whatever their environment has done to them, and the multiple strains of genetic information that we're getting from all of our ancestors, it's a very, very complicated picture, and
Yeah.
one that, that I think is going to yield a lot of challenges for the next 20 years of the Movement Disorder Society.
It does you frame up really interesting questions about, because you have to wonder, have we maxed out sort of neurotransmitter-based therapeutics for Parkinson's disease? And I think based on this line of thinking, no, there's maybe a lot to discover and how to harness some of these plastic changes. And I know we only have a few minutes left, so I just want to fast forward a bit and just ask you two questions. And maybe I'll have one more after that. So what are
I've
you
never known you to stop.
succinctly, what are you excited about now, and also what sort of advice would you have for young investigators who are starting their careers now and interested in these areas?
I'm excited about our new generation of synuclein-based therapeutics, and as well as the genetic targets that we have, not just the two big ones, LRRK2 and GBA, but starting to understand all the pathways that are potentially upstream, downstream from synuclein. So there's a real fertile ground for drug discovery research. Right now we're entering the first of the next generation. You know, we're starting to boldly go.
Yes.
And I think, you know, just like Star Trek, which has been on the air for ever since the first Levodopa trials. This is also the 50th anniversary of Star Trek.
Right.
So going boldly, there's a whole universe of stuff
that
remains to be discovered. Can we develop non-dopaminergic symptomatics? Can we develop better symptomatics for treatment of cognition? How do we integrate all our understanding of the genetics and the pathways to really come up and with truly well-tolerated, safe drugs that we can give to patients for long-term economically? I think the challenges in the healthcare system, understanding the epidemiology, the impact of Parkinson's disease on people's lives is going to be important for us in demonstrating the value of therapies to payers and governments. That's going to be very, very important, because we're all going to have to be proselytizers, engaging our patients in research, because we're not going to be able to do this without support of as many Parkinson patients and families.
Heroic patients who are willing to
these
work
heroic
on these.
Patients. They may not have stuff to gain and anything to gain in the early stages, but they contribute. But expanding that, getting them to share their experiences with others. I'm really excited at the possibility of being able to perhaps do at least secondary prevention, like they're doing in Alzheimer's disease, like Eduardo talked about in his kickoff talk this morning about identifying prodromal PD, and at the earliest signs of non-motor or perhaps subtle motor dysfunction, being able to start to treat people. Now that has a lot of issues along with it, and I don't want to be glib about it, because there are ethical issues, there are economic issues, there are scientific issues, but we have the ability, the potential, maybe not in your and my lifetime, but
I'm hoping we're going to go for a while.
I'm hoping we're going to get there with what you're doing, with what we're doing, with what everybody else is, but certainly with the next generation of investigators to prevent Parkinson's disease, and maybe Huntington's and ataxias and all kinds of things. We're really on the threshold of being able to do that. And that's what it's all about.